Have you ever wondered how a single voice can echo through time and transform the way an entire civilization views the universe? That's exactly what happened when Carl Sagan, with his turtleneck sweater and his characteristic diction, invited us to embark on the ship of imagination. Born in 1934 in Brooklyn, Sagan wasn't just a brilliant astronomer, but a natural communicator who could translate the mysteries of the cosmos into everyday language. His passion for astronomy emerged in childhood, when he would marvel at the starry sky of New York, wondering what might exist beyond those luminous points. This childlike curiosity never left him. On the contrary, it became the driving force that propelled him to become one of the most important science communicators in history. The series Cosmos: A Personal Voyage, launched in 1980, wasn't just a television program. It was a revolution in how science was presented to the public. Imagine the impact. In an era without the internet, more than 500 million people in 60 different countries gathered in front of their televisions to follow Sagan on a journey through the confines of time and space. The program combined visual effects that were innovative for the time, engaging music, and Sagan's passionate narrative to create an almost mystical experience of scientific exploration. Billions and billions, the phrase that became his trademark, although he claimed he never said it exactly like that, captured his ability to help us comprehend the vastness of the cosmos without feeling diminished by it. Look around and think how many scientists, engineers, and modern explorers had their first spark of interest ignited by Sagan. Neil deGrasse Tyson, who would later present the continuation of Cosmos, recounts that at 17, he received a personal invitation from Sagan to visit Cornell, where he was a professor. Although Tyson chose Harvard, this gesture of generosity from Sagan deeply marked him. He wasn't just interested in sharing the universe with the public, he wanted to create the next generation of scientists, Tyson reported in various interviews. Sagan's influence on the evolution of science communication is comparable to a supermassive black hole at the center of a galaxy. Everything around it is inevitably attracted and transformed by its presence. Sagan's approach to science was unique because it combined scientific rigor with a profound sense of wonder and mystery. Somewhere, something incredible is waiting to be discovered, he would say, conveying the idea that scientific exploration wasn't just a cold intellectual exercise, but an exciting adventure. In Cosmos, he took us from the beginning of the universe to the possibilities of the future of human civilization, through the evolution of stars, the origin of life, and the development of intelligence. His metaphor of the cosmic calendar, which compressed the 13.8 billion years of the universe into a single Earth year, helped millions of people understand the scale of cosmic time. On this scale, all of recorded human history would occupy only the last few seconds of December 31st. But perhaps the most revolutionary aspect of Sagan's approach was his ability to connect science to the deepest questions of human existence. When he spoke about the billions of galaxies, each containing billions of stars, he wasn't just reciting astronomical facts, he was inviting us to reflect on our place in the cosmos. In a memorable episode, he presented us with the pale blue dot, the image of Earth seen by the Voyager 1 probe from a distance of 6 billion kilometers. In that photograph, our planet appears as a tiny blue dot in a vast ocean of darkness. Look again at that dot. That's here. That's home. That's us, narrated Sagan with his characteristic voice. This reflection on our smallness in the universe didn't diminish us. On the contrary, it made us value even more our precious spaceship Earth and the responsibility to preserve it. This connection between astronomy and the future of humanity naturally leads us to explore how Sagan revolutionized the field of astrobiology and the search for life beyond Earth. When we talk about astrobiology today, it's almost impossible not to mention Carl Sagan's name. But did you know that when he began to seriously advocate for the search for extraterrestrial life, many scientists considered it a waste of time or even pseudoscience? It's as if Sagan was navigating against the current in an ocean of academic skepticism. In the 1960s, while most astronomers focused on phenomena like quasars and pulsars, Sagan was already questioning the possibilities of alien existence with the scientific rigor that characterized him. Absence of evidence is not evidence of absence, he used to say, challenging the paradox that surrounded the search for extraterrestrial intelligence. Sagan's contribution to astrobiology was so profound that it's comparable to the discovery of a new continent on the map of science. As a co-founder of the Planetary Society and tireless advocate for space missions, he helped transform the exploration of the cosmos into a scientific and cultural priority. Think about the Viking missions to Mars, launched in 1975. Sagan was one of the scientists who designed experiments to detect signs of life in Martian soil. Although the results were inconclusive, these experiments established a precedent for all future missions searching for life. Whether we're looking for microbes on Mars or signs of advanced technology in distant stars, he explained, we're really asking the same fundamental question: are we alone in the universe? Sagan's vision about the possibility of extraterrestrial life was simultaneously bold and cautious, a paradox that reflected his scientific approach. On one hand, he constantly reminded us of the vastness of the cosmos. There are more stars in the universe than grains of sand on all the beaches of Earth. This simple but powerful analogy helps us understand the scale of possibilities for the existence of civilizations beyond our own. On the other hand, he was extremely skeptical about reports of alien visits to Earth, demanding extraordinary evidence for extraordinary claims. In his book, The Demon-Haunted World, published shortly before his death in 1996, Sagan critically analyzed the phenomenon of supposed UFO sightings and alien abductions, demonstrating how scientific thinking can protect us from believing falsehoods without diminishing the mystery and wonder of the real universe. Perhaps Sagan's most enduring contribution to astrobiology was his ability to expand our imagination about how life could evolve in environments radically different from our own. Life on Earth is based on carbon and water, but that doesn't mean all life in the cosmos must follow the same pattern, he argued. In collaboration with other scientists, Sagan speculated about the possibility of silicon-based organisms or creatures that could float in the dense atmospheres of gaseous planets like Jupiter. These weren't mere fantasies. They were rigorous scientific exercises that broadened the horizons of biology and chemistry. Today, when astronomers discover exoplanets in the habitable zone of their stars, or when probes explore the subsurface oceans of Europa and Enceladus in search of life, they are following a path that Sagan helped pave. Sagan's influence on astrobiology also extended to the field of interstellar communication. He was one of the principal architects of the Arecibo message, transmitted in 1974 to the globular cluster M13, 25,000 light-years away. This message contained basic information about humanity, our solar system, and our biology. More famously, Sagan led the team that created the Golden Records of the Voyager probes, cosmic time capsules containing sounds, images, and greetings from Earth, destined for any civilization that might find them in the distant future. The Voyager spacecraft are a kind of bottle launched into the cosmic ocean, he explained, a message to possible civilizations in stars not yet formed. This initiative wasn't just a scientific exercise, but a profound act of hope in the existence of a galactic community of which we might one day be part. Sagan's legacy in astrobiology lives on in current NASA missions and those of other space agencies. The Perseverance rover, which landed on Mars in 2021, carries sophisticated instruments to search for signs of ancient microbial life, a search directly inspired by the questions Sagan raised decades ago. The James Webb Space Telescope, launched in 2021, has among its main objectives the analysis of exoplanet atmospheres in search of biomarkers, gases that could indicate the presence of life, and the SETI program, Search for Extraterrestrial Intelligence, which Sagan passionately defended, continues to scan the skies for artificial signals. As he predicted, if there are thousands of civilizations in our galaxy, then surely some of them are much more advanced than ours. Wouldn't it be extraordinary if we could learn from them? This bridge between rigorous science and the exploration of the unknown naturally leads us to the third aspect of Sagan's legacy, his impact on promoting scientific curiosity and the peaceful exploration of space. There is something profoundly transformative in hearing Carl Sagan say, "Somewhere, something incredible is waiting to be known." This simple phrase captures the essence of how he revolutionized our relationship with science, not as a distant body of knowledge reserved for specialists, but as an adventure accessible to all. Sagan understood that curiosity is the engine of human civilization, the impulse that took us from caves to the stars. In a world increasingly dominated by technology, he perceived that scientific illiteracy represented a real danger to democracy. We live in a society exquisitely dependent on science and technology, he warned, in which hardly anyone knows anything about science and technology. This contradiction motivated him to dedicate a large part of his career not just to doing science, but to sharing it with the public in innovative and accessible ways. What makes Sagan's legacy so extraordinary is that he managed to democratize scientific knowledge without ever simplifying it to the point of distortion. Think about how he explained complex concepts like relativity or stellar evolution, always with precision, but using metaphors and analogies that anyone could understand. In Cosmos, he invited us to imagine the universe as an ocean of darkness speckled with billions of archipelagos of light, transforming astronomy into poetry without sacrificing scientific rigor. This approach inspired an entire generation of science communicators, from Neil deGrasse Tyson to Brian Cox, who follow his example of making science simultaneously precise and exciting. It's not an exaggeration to say that, without Sagan, many of the scientific and technological advances of recent decades would not have received the public support and funding necessary to materialize. Sagan's vision of space exploration was inseparable from his concern for the future of humanity. In the midst of the Cold War, when superpowers saw space primarily as an arena for demonstrating military superiority, Sagan advocated a radically different approach. Space is not a competition, but a frontier for all humanity, he argued, frequently reminding us that seen from space, our planet reveals no national boundaries. In 1983, he was one of the scientists who introduced the concept of nuclear winter, the global climatic catastrophe that could result from a large-scale nuclear war. This research not only influenced disarmament policies, but also reinforced his conviction that space exploration should unite humanity, not divide it. If we are to survive, our patriotism must be tempered by an equally strong conviction of global community, he wrote, envisioning a future where space technology would be used for the benefit of all. Sagan's impact on science education transcends generations and borders. How many children, after watching Cosmos or reading The Demon-Haunted World, decided to pursue careers in science and technology? Impossible to quantify, but the testimonials are countless. In universities around the world, professors report that decades after his death, Sagan continues to be cited by students as their main inspiration. His educational legacy goes beyond the content he taught. He showed us how to think critically, how to question dogmas, and how to keep an open mind without abandoning healthy skepticism. Science is more than a body of knowledge, he insisted. It is a way of thinking, a form of penetrating skepticism. In an era of disinformation and polarization, this lesson is more relevant than ever. Perhaps the most visionary aspect of Sagan's thinking was his understanding that space exploration is not just a matter of scientific curiosity, but of species survival. Earth is the only world known so far to harbor life, he wrote in Pale Blue Dot. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes, settle? Not yet. Like it or not, for the moment, Earth is where we make our stand. This reflection wasn't an argument against space exploration, but a reminder of our responsibility toward our home planet. At the same time, Sagan passionately advocated that we become a multiplanetary species as insurance against possible catastrophes. The dinosaurs didn't have a space program, he observed with his characteristic humor, alluding to the extinction that could have been avoided with advanced technology. Sagan's legacy continues to expand, like the concentric waves that form when a stone is thrown into a lake. The SETI home mission, which allowed millions of ordinary people to participate in the search for signs of extraterrestrial intelligence by donating their computers' idle time. The Planetary Society, which he co-founded and which continues to promote space exploration and the protection of Earth. The new version of Cosmos, presented by Neil deGrasse Tyson, and even the growing acceptance of astrobiology as a legitimate scientific field. All these are fruits of the seeds that Sagan planted. In 2011, NASA launched the Mars Science Laboratory mission, whose rover, Curiosity, appropriately named, landed on Mars in 2012. The landing site was officially named Aeolis Palus, but is informally known as Bradbury Landing, in honor of science fiction author Ray Bradbury. It wouldn't be surprising if, in future missions, some location on Mars or beyond received Sagan's name, an appropriate recognition for someone who dedicated his life to expanding the horizons of human exploration. When we look at the starry sky today, we see not just points of light, but potential solar systems, possible cradles of life, future destinations for humanity. This change in perspective, this expansion of possibilities, is perhaps the greatest gift that Carl Sagan left us. As he himself said, astronomy is a humbling and character-building experience. There is a beauty and an awe up there that is transcendent. It lifts you above yourself, above your small concerns, above your mundane problems. It is larger than life. In a time of unprecedented global challenges, Sagan's legacy reminds us that looking to the stars is not escapism. It's finding perspective and inspiration to solve problems here on Earth, while simultaneously preparing the way for the next great leap of human civilization.